Ladies and gentlemen, good morning. My name is Jeroen Koot. I'm the CEO of Heaton, and I will be talking about high-temperature heat pumps, applications of high-temperature heat pumps to decarbonize the industry. So, large power and high temperatures. I have a couple of cases, and I have some news for you. We are also here with our equipment, and you can see it at our stand. So if you want to do so, several of my colleagues are here and will be able to help you there. As a brief introduction for Heaton, who are we? We are a company with 2 locations in Norway and in Germany. We make high temperature heat pumps. That means up to 200 degrees. That is a significantly high temperature. That means it's about steam. It's about water to steam, and it can also do water and hot water. We're talking about equipment with a lower capacity of 1 megawatt and a higher capacity of 2 megawatt now, and next year 8 megawatt. And it's based on a piston-based technology. And I will tell you a little bit more about that in my presentation, because that's important for the applications that we are looking at. Just as a little bit of a background, our company was started somewhere in 2010-11. We started developing this technology, and it has developed the technology for 13 years now. First it was Viking heat engines, now it's Heaton. And we do have this 2 megawatt compressor that is the breakthrough technology that we are now presenting on this fair. We also have our next sights on the bigger machine, because we know that our customers, our big industrial customers that have a heat need of about 50 megawatt or so, really need a big machine in order to be able to decarbonize and save their energy. We also have other news. We are a company that was growing and developing a technology, and last week we have found a partner that is investing in us significantly. It's a large private equity party that has created the funding for our growth. And in that group, there is a second party that will help us to grow, to develop our technology further, to roll out, provide the service, but also with the financial backing of a very large party. So we are very excited to announce that here. It was already in the press last week, but it is important for us that we're ready to grow. Coming back to our product. So what is the solution that we're offering? It's an evolving solution. We started with a small machine, the heat booster, which only had 200 kilowatts. That's a machine that is running with customers, has done tens of thousands of hours, and we are now in the next phase. We're rolling out, as we speak, 2 customers with our 2 megawatt equipment and the compressor that's currently here on the stand in Choventa. And next, we have started development of a V16 compressor, piston-based compressor. It looks like a big engine, a big combustion engine. That's no coincidence. That's also why we are teaming up with parties like the party INEO that can really help us scale this opportunity and also decarbonize and change the world with this technology. Now, what is it that this technology does? It reduces cost, as all heat pumps. It reduces carbon footprint, as all heat pumps. But then there is a difference here. This is very flexible equipment. It's very easy to configure, and that is what is the big difference with piston-based compressor technology. The target, the area that we are targeting, I see you making pictures. In my last slide, by the way, there's a QR code, and you can download the whole presentation. So Don't worry and ask questions. That's what I like more. The area that we are targeting is somewhere from 1 megawatt until 10 megawatt or more if we start building systems with that. But our current equipment is targeting that segment from roughly 90 degrees up to 200. That's where there's a lot of demand, where there's a lot of need with industrial customers to find solutions in order to be able to decarbonize and to save energy. Coming back to our technology, what is the real difference for that technology? What is unique about our heat booster technology? It's piston-based and gives a couple of very big advantages. First of all, it's the performance, the amount of power that you can put in one machine, and therefore it has a very small footprint. But also the efficiency. The efficiency is constant from 20% load up to 100% load. We don't have to recirculate or those kinds of things to keep the machine running. We just tune it down, and by tuning down, the efficiency even goes up. And that is key to piston-based technology. Now, the next thing which is important for applications is the size and range that we offer. It's exactly in this square that I was just showing you. That's where we really can bring a difference, make a difference. Thirdly, it's the scalability. It's very easy to have redundancy by putting several machines in parallel. And because you can tune them down, it's very easy to configure. These machines can also take any refrigerant, hydrocarbons, and HFOs, whatever your customer needs. And the only thing we have to do is do a little bit on the electricals, but the rest is just configuration by software. So it is a big advantage to use this solution. Lastly, the fact that you can just do this and scale this to a V4, a V12, a V16, a V20 makes it possible by using standard equipment, standard manufacturing technology to really scale this solution. So a customer should not have any fear of using it because it is standard operation, standard equipment that already exists for hundreds of years. And the benefits will be for our customer and whomever is going to help us roll that out. Now, I promised you to talk about some cases. So let's have a look at what kind of industries we see as the first to take these kinds of solutions. Yep. First of all, food and beverage. Food and beverage, if you're not decarbonizing in that industry, you're losing your right to access the market. There is an enormous pressure from the food companies for any supplier to reduce the carbon footprint. And we are talking to a lot of people, a lot of companies that really need this. And if you're in that sector, come and talk to us because we have the solution for that. Secondly, district heating, a lot of things are going on there. There's many different solutions that we can do there. It's lower temperature, but think about in a district heating solution, taking the heat from the district heating solution and then making steam out of that for a certain customer, selling it as a heat in a different manner. That is possible with our solution because we can produce steam. Thirdly, paper and pulp. A lot of heat goes in it. It's in the megawatt class, and they all need steam to actually do what they need to do. They are in the high temperature ranges. That is a big solution that we can offer there. Chemicals, it's a big basket of many processes. Could be anything, but just saving energy and saving carbon footprint in the chemical industry is possible. It could be rubber. It could be a distillation column. It could be anything. And lastly, an area that I really want to address as well is the whole new area of power to X, carbon capture, electrolyzing, where you have huge streams of heat that needs to be taken away to cool the equipment. And for that, you need a solution. And we can offer that. Let's go into a couple of details for these. Remember again, our target temperature is up to 200. Target power, 1 to 50 megawatt, roughly. Industrial solutions. Heat source, somewhere between 10 and 150. So we can also do steam to steam. But you can also start at 10 and bring it up there. Our preferred area is where we're really good. That's in the high temperatures. And the heat sink, somewhere between 90 and 200. A solution, this is one. The agricultural world. Now, there is this a big potato here in the middle. And everyone would be looking, that's an egg or whatever it is. No, it's a potato. It's the industry of making starch. It's the industry of drying peas, grinding peas, making ingredients out of those. They use a lot of heat for drying, and that's what we can bring there. We take their return streams, their waste streams heat, we bring them up again and make steam for them. And with that steam, they can, got a big echo here, sorry. We actually bring a solution in saving energy for them. Paper, I already addressed. There's a lot of steam needed in that industry to dry the pulp and also take away the steam that comes off the web, condense the heat that comes out of that, recover that heat, and then feed it into the system again. We're recirculating heat. Chemicals, similar type of thing. I keep on repeating, but just to make sure that you get the message. And I have some COPs that you can use here in these slides. We're talking about COPs, number 2, 3, 4, even 5 we've seen with certain customers. But it's very dependent. It's determined by thermodynamics and a very efficient heat pump. Anyone in this big show that knows anything about thermodynamics can confirm to you that it is the parameters that determine the COP. But this is the COPs that we have seen with certain processes of our customers. So that means that you probably only need 20% of the energy in the end to actually run your plant instead of 100. Lastly, or one before last, this is a big carbon capture company that needs an enormous amount of heat pumps to actually make the system work. That's the things that we are targeting as well. And lastly, one of the real big markets, but lower temperature, is the district heating. If you want to know more, please come to our booth. Come and see our compressor, as this is the picture of it. Come and see it. Scan the QR code and you'll have this presentation. We are at 4203, which is diagonally from this hall, and we were happy to answer any questions. If you have any questions now, I'll be very happy to take those questions now and share them with other people. Yes.
What is this for?
The COP will go up at partial load because the efficiency of the compressor goes up at partial load, but the COP is primarily determined by the temperatures of your input and your output.
How the control the capacity?
How we control the capacity? We just tune down the RPM. Very simple. It's a frequency controller on the motor, and we tune down the motor, and it will do the same thing.
And we stick up. until that's really
Can you speak up? I can have trouble hearing you, and if I walk forward, I have the echo. Can you speak up a little bit?
take out the least possible. At last, some more. Even or
I cannot hear a question. Please.
so.
So either, and I will repeat the question.
Do you make out of the operation the discuss? The particle for only to quest breathing.
No, it's frequency. So the question is how we modulate the machine, how we tune down the machine. That is by reducing the RPM. It's not by taking out pistons. It is very robust, in a way, standard technology for a few fixes that we found that actually make it possible to have the compressor with the largest swept volume and the largest compressor that can actually do a high temperature heat pump.
Hugs the right will be that
The main determining factor,
be better like in the car.
we have designed our compressor for 20 years lifetime. It's like an engine. You have your regular maintenance, but then the lifetime is determined by simply the normal wear that you would see in an engine. And then you need to do an overhaul every 10 years or something like that, which is for standard diesel engines, the same thing, or gas engines.
They'll be installed there, can I?
Yeah, question is if we already have installed machines. Yes, we have. So we have installed the smaller ones, but we also have this 2 megawatt one we have with a customer at this moment. And we have others that are being delivered right now. So it's not the first one. And the one that we delivered has seen an enormous long duration test. So it's not a prototype anymore, but just to take away any doubt there. Any other questions? If you want, come to our booth, see what we have, what we show, and ask questions there if you want to do it on a one-on-one basis. And we are able to deliver you in next year. So if you want that, you can have this machine in your plant next year. Thank you.